And welcome to what is going to be the final session in our series, AI Spring, a really wonderful series that is we've uploaded to our YouTube channel. It's been really quite an extraordinary journey. We end up in the city itself. I should say that just before I introduce our speakers, to say that a couple of announcements to make beforehand. Firstly, the Digital Intelligence, the Digital Futures Conference. The deadline is the 29th of November, so it's coming up, and I really recommend people make a submission to this. It's completely free. You don't have to pay anything to register. It's certainly very interesting, very interesting conference. The second thing is that last week I announced the fact that there are a couple of NSF-funded posts for doctoral design posts at FIU. I've put the QR code in this time, which if you scan it, it'll take you directly to the link. The deadline is the 1st of December for these particular things, particular fellowships. You have to be either an American or a green card holder for this. But there are other posts that will be advertising. Opening up at the bottom here, we have the link to the DDes program. And in January of next year, we'll be accepting further applicants for the Doctor of Design program at FIU. But these ones are on the 1st of December, need to be submissioned by then. So today then, we come to the final session. I'm delighted to have Imdat, who is a very distinguished scholar who's been producing a lot. He's been based in Harvard. He's now at the Istanbul University of Technology, he's the author of 2 books, and Silvio Carta from the University of Hertfordshire, which is very close to where I used to live in Cambridge, is also with us today. Imdat is from Turkey, and I want to mention that we have our first ever Turkish language channel session with Digital Futures coming up on the 3rd of December. It's going to be a big step forward for us, and I'm really looking forward to that because I am always surrounded by very fabulously talented Turkish individuals. Memo Aktan's given a lecture on this course. There's also Govic Ozol and Refik Anadol and many others. So this is a great step forward for us. Silvio is from Italy. I never know why Italians want to live in the UK, because as a UK citizen, I always want to live in Italy. But anyway, he lives in the UK. So this is the final one of the series. And as I mentioned before, they're divided into 2 sections. The first section was looking at how these new platforms, the diffusion platforms, have really taken the architectural culture by storm and really made people wake up the possibility of AI. And then also the books that have come out this year. 2022, the thesis is going to be the year in which will be known as the year in which architects woke up to the possibility of AI. That's not to say things haven't been going on before, but rather this is the moment when people are beginning to wake up to these things. And it's because of these diffusion platforms that have made such a step forward from the GANs, generative adversarial networks, so that from the highly labor-intensive, I should mention that this is Refik Anadol's image on the left-hand side. So anyone can now produce these things very quickly without much technological knowledge and with much better resolution. So on the right-hand side, an image that was generated by Midjourney. But it's the books we're focusing on in this last section. We've already looked at a number of books over the last few sessions, and today we come to the city itself. There are 3 books, in fact, that have been published on AI and machine learning in the city. I'll start with Imdat As's first book on the left-hand side, The Routledge Companion to Artificial Intelligence and Architecture, which came out in July 2021. His second book, Artificial Intelligence in Urban Planning and Design, which I contributed to, has come out in July 2022. And then Silvio's book, Machine Learning in the City, also came out in July 2022. It seems that July is a popular month in which to publish these books. So let me just simply, before welcoming Imdat and Silvio to make some presentations, let me give some background thoughts for this session. In my own book, I raised the question, what will the city of the future look like? And I put this question to Midjourney. And I'm always shocked by how much better and better it's getting. And this is the kind of quality, the resolution that we're getting from Midjourney. This is what Midjourney predicts, shall we say, that the city of the future will look like. All I can say is that if since the development of from DALL-E to DALL-E 2 to Midjourney, things have got so much better, Who knows what will be available next year, but we're already able to generate these extraordinary images, the resolution of which is bound to get even better. And these are, I think, this is why I think maybe architects are really waking up the possibility of what AI can be, because we're visual creatures. We need to see visual evidence of this. And GANs, for all the work on GANs, they failed to deliver convincing images. And I think architects really depend on this. So I'm just going to click through these. It kind of reminds you in some ways of what of a kind of Hugh Ferris of the contemporary age. How when you think how much time Hugh Ferris would have invested in each of his extraordinary paintings of New York. These things can happen just in the space of this. All this work I'm showing you here was generated in the space of about 2 or 3 hours, and we can do extraordinary things, visionary things. I mean, in many ways, they're just two-dimensional images. They don't have any sense of materiality or performance, but at the same time, they are scenographic. I can imagine them within the movie industry, with the gaming industry being taken up and pushed further. So we have this significant development, which has really shocked architects into the capability of what AI can do, and it is remarkable. But is this what the city of the future will look like? This is certainly what Midjourney tells us, at least according to a certain prompt that I gave it, tells us that it will look like. It is going to be this metropolis with these astonishing towers, a kind of somehow a cross between Dubai and New York and Shanghai all together. But is that really what it will be like? Will it be this kind of futuristic, slightly dystopian city that we get when we start exploring these possibilities through Midjourney? Or will it be something very different? Might it just look pretty much like the city that we see today? So let me just click through the last of these images. As I say, that all these, if you're interested in Midjourney, the place to go is to Instagram. There are a lot of accounts now, and this is my own account at the bottom there, Neil14. You can see some of these. This is where I upload these images. But is this, I mean, astonishing as this vision is, as remarkable as it is, as futuristic as it is this what the future of the city will be like? Will it be a kind of Blade Runner, kind of Jetsons kind of view with flying cars and the astonishing skyscrapers, or will it be something else? I want to reflect back on something that I published back in 2009, Digital Cities. This was an issue of architectural design, which was speculating what is the impact of digital technologies on the design and analysis of cities. So what will the impact be of the design? On the front cover, we have some work from Zahadid Architects, and the vision of Patrick Schumacher, who in the first article in the issue, is when he launched his idea of parametricism, and he spoke about this new global language, and spoke about how the city of the future would be the parametric city of the future. This is the study that the Zahadid Architects did for Singapore, and then one for Istanbul, that neither of which were realized, but were astonishing in their own right. And also this proposal for east of London, that itself was definitely not realized. And the question is whether or not, in fact, any parametric city or any city of any kind of computational city has ever been realized. And we can point towards maybe all the aggregation of all the projects by the office, which I think is an amazing thing. Historians are going to look back on this moment in architectural history and look at offices like Zahadid Architects and say, well, collectively, they were producing one of the biggest airport in the world. They were producing something, an astonishing oeuvre of work that, in itself, if you put it in together, would come to a kind of a city in its scale of it. But no one city has really been designed according to that, for obvious reasons to do with economics, planning, control, and so on. At the end of the book, the AD, the final article, was an article by Ben Bratton, who really took a very different position to the architects. All the architects were saying, this is what it's going to look like, and giving us these visions, these futuristic visions. And Ben Bratton makes a very simple comment in a really, what I think one of the most beautiful articles that I've seen, iPhone City, that really what has really changed the city and will change the city in the future is really information technologies. And he writes about it in terms of how, with this simple iPhone, you could now navigate the city in a completely different way and understand it in a different sort of way. And how this has enabled, and this is, of course, this is written in 2009 before these things were illegal. You could text from your car, so that your car became the office, and it was to and so 2000. This was written in 2008, 2009. The first version of the iPhone the iPhone came out, so he was ahead of his time in many ways. So the question is, well, what from an architectural perspective, certain commentators have. We always tend to think, well, these architectural historians like Mario Carpo tend to think about the world in terms of a kind of style, as though the digital turn is a style in architecture. And for him, the second digital turn was also a question of style. And he looked at big data and thought, well, big data, he read somewhere, big data is messy, therefore the architecture of big data is going to be messy. My point would be that actually the architecture of big data is going to be not about the what it looks like, but how it operates. And you can take the example of the Uber car and think about it in terms of how that operates. And does an Uber car look different to an ordinary car? No, because it is an ordinary car. It's simply operating in a different way, harnessing the AI technologies in order to be able to operate more efficiently. It is a question of process, not a representation, but about process and how the world itself changes. So what will the city of the future look like? Will it be something out of the Jetsons, out of Blade Runner, or whatever? Well, this is actually an image of LA and where I am at the moment. And I would say that really this LA of the future, there has been developments in downtown, of course, just recently, but the LA of the future will look largely like LA of today. And indeed, as will London or New York or or Tokyo. There will be a few new buildings, but the main change is going to be the existing building stock will be retrofitted, and the existing city retrofitted with various state-of-the-art technologies, including, of course, AI, and will operate in a very different way. It won't necessarily look so different, but it'll operate in a very different sort of way. So in my book, Architecture in the Age of Artificial Intelligence, I do touch upon, there's a chapter that's dedicated to the city of the future. And I pick up on the notion that Manuel Castells had put forward, the idea of the informational city, the importance of information and informational processes in the cities of the future. And I then step up and look at the work of Ben Bratton, who in a sense three-dimensionalizes that image, that concept of the informational city, and talks about what the stack, this accidental megastructure, where you have these interconnected layers, these 6 different layers of which the city comprises one. Whether or not this is the case, but this is simply Bratton's thesis. And he puts forward this kind of, I think, fairly convincing thesis about how we will operate in the city. And certainly as we shift from the straightforward smart city to a city in which AI plays an important role, we are going to see a significant shift towards a different type of city. Back in 2017, I produced this book on the right-hand side, Swarm Intelligence, with Ron Snooks. And this was building upon the discourse of swarm intelligence that has already existed. In 1999, the first book on swarm intelligence, Eric Bonobo, Marco Dorigo, and Guy Terrales, remarkable book, but it wasn't until Stephen Johnson was able to produce this book on emergence that really became completely accessible, this best-selling book. And the important thing about the book, I think, is the subtitle, The Connected Lives of Ants, Brains, Cities, and Softwares. And what I did in my chapter here, I really make the connection about how software, artificial intelligence, is going to help the city operate as a kind of brain. The idea that the brain that the city is already a kind of brain, and there is a sort of low-level intelligence there, has already been explained in this logic. And what do we mean by swarm intelligence? Well, there are many different manifestations of what we see as swarm intelligence. Whenever you get a multi-agent system, and here we see a flock of starlings, a murmur of starlings, coming together in a bottom-up way, and generating this astonishing pattern. This isn't a manifestation of what happens with swarm intelligence. A kind of low-level intelligence comes out of interactions and very simple interactions following the basic rules, keep going the same general direction, the same speed as the birds around you, and go approximately in the same direction. And this is one manifestation of it. We can also see swarm intelligence, of course, in many other manifestations, wherever that logic appears. So we can see it, for example, in sardine runs. We can see it also, I would argue, in the way that cities are laid out, the similar sort of logic, keeping a certain distance, going broadly in the same direction. Here, a village in a Greek island, following the contours, as it were, of the land. And there are many examples you can find of this kind of logic in more traditional forms of architecture. So already we have a kind of a logic which connects the city with the brain with a form of intelligence. And what I would simply do in my article is, in my chapter, is to take that further and to say, well, maybe what's going to happen in the future is that we're going to enhance that with the use of AI, and we're going to develop a form of brain city. And I mentioned this one particular case, which doesn't have many images to illustrate it very well, but in China, there is already a company called City Brain that is using AI to understand the city through a kind of digital twin model, whereby you're monitoring the city in real time and using it to enhance the city, to make it operate in a more efficient way. So we can see that this is the kind of thing that City Brain does. It basically, it tries to work out how you can spot accidents, get them there, and get emergency vehicles there earlier, and how you can, in fact, relieve the kind of traffic jams that which the contemporary city has been based. And it would seem, from what we can see, that in fact that is the case, that cities are being traffic flow and other things in cities are being enhanced by the operation of AI. So my argument has been is just that as the argument has already been made in terms of what we get in terms of the intervention of AI is not necessarily humans versus AI so much as AI becoming an extension of the intelligence of humans. I argue in this particular article that this chapter that the low-level intelligence that exists already in the way the city operates is enhanced by AI. So we have an AI-enhanced city of the future, and my prediction then is really not the city of the future is going to look like something out of Midjourney, but rather it's going to operate in a fundamentally different way, where AI is going to be harnessed, and we're going to have this concept of, as I put it, of the brain city. Well, my article is very sort of theoretical and in a sense superficial compared to the research that's been put together by Imdat and Silvio. So I will just simply stop at this moment here and invite Imdat to make a quick presentation, which we do not quick presentation because he has 2 books to present. So Imdat, welcome. It's great to have you here, and it's great to have it so close to the first ever Turkish language event in Digital Futures. Welcome.
Thank you, Neil. I wonder if I'm already, if you can see my screen.
Not yet.
Okay, just a second. There you go. Oops.
We can see now.
Yeah, just a second. Okay. Can you see it now?
Yes.
All right, excellent. Thank you so much, Neil, for the introduction, and thank you for inviting me to this amazing Digital Futures Doctoral Consortium series. I really enjoy your sessions. So I'm going to talk today about these 2 books. One I published in 2021, The Routledge Companion to AI in Architecture, and the other one Neil mentioned in 2022, the AI in Urban Planning and Design. And I want, in the beginning, before I go into the books, I just want to give a little bit of context of where I'm coming from and how I got into this field of research. So if you look at the American the built environment, the building inventory, most of these buildings that you see are sort of cookie cutter buildings. There are about 150 million of them in the United States alone. And in a lot of these buildings, we as architects actually don't have a lot of agency. We don't have a lot of market penetration into what's going on here. So this was actually depicted very sort of nice in this caricature by Leon Krier, saying what we learn in architecture schools and what the sort of the outside world wants and lives in. Of course, he's sort of advocating that we should change the curriculum and teach sort of neoclassical architecture, right? But my concern was, how can we actually increase our design footprint and sort of do what we have been taught in architecture school, and how can we sort of leverage digital technologies to do that? So that was sort of where I was coming from. Just to give you a couple of numbers here, so in the United States, there are about 15 million architectural projects each year. And these numbers are a little bit outdated, but proportionally are probably still very similar. So about 3/4 is design work, actually, that we as architects could be part of. And 1/4 is repair and maintenance. These are sort of projects that, you know, fixing your roof, fixing the sidings and the basement and so on. However, out of these projects, actually only 10.1% work with an architect and have professional support. This is also sort of a question about our profession, how much we can actually impact our built environment, and about 90% are actually done without an architect. And this is not only an American story, but it's also a global story. So it's twofold, right? On one hand, we want to get more of these projects to have more impact on what's on our built environment and beautify it. On the other hand, there's also this question that you raised in one of your earlier sessions, where what if these 90% of project owners all of a sudden come and say, we want to work with an architect? There is actually not enough architects out there. So it's also not scalable in a way. So that's the reason why AI and all these sort of technologies could be promising and sort of helping us to address these issues. Now, when we look into a building's life cycle, we can actually put it down into these distinct phases. So it has the pre-design, schematic design, design development, sort of conceptual design phases, the construction documents phases, the permitting and bidding phases, and then the construction administration, the sort of building of the work on the site. And this is more or less true for every country, not just the United States. So they just rename it slightly, but in essence, it's the same phases. So when you look at the first couple of phases, these phases could be actually global phases. So the schematic design and pre-design and design development phases. As a matter of fact, when we're in architecture school or when we participate in competitions, right? We live in Boston, let's say, and participate in a competition in Korea. We are actually participating within these sort of first couple of phases, and the construction documents, permitting, bidding, and construction administration phases, they are more locally and are done where the physical edifice is going to be built. So the idea was I had early on was, can we actually crowdsource these phases and use some of the design talent around the globe to work on these projects where architects never have a chance to work on. So we started with a couple of friends, Art Bazaar, which is a crowdsourcing platform. So people can upload their projects and launch a competition. And then designers from all around the world simply submit their designs. The project owner picks the top 3 winners, and then we distribute the awards. So if you look at the acquisition models of design, traditionally, the project owner would go to an architect, get a design, or follow the RFP model, the request for proposals model, where actually he would or she would invite a couple of designers to submit their proposals and then interview them and then pick one and acquire the design in that way. Or the competition model. I mean, this is a very old traditional model done centuries right now. And so in this case, the project owner hires a competition agency, which forms a jury, launches the competition, and then picks the winners, and the project owner gets the design. In the crowdsourcing model, we actually get rid of this sort of interim step, and the client has all sort of the power, or the project owner is sort of empowered to decide what the award is, what the duration is, and who the winning designers are. In an interesting way, in a lot of these projects, the project owners actually use a couple of these designers, not just, let's say, the winning designer, but also the second or third, and pick certain pieces of them and create sort of Frankensteins out of these competitions. Of course, this is sort of a nightmare for designers, but if there is a way for crediting this in a correct manner, it can also be an incentive for designers to participate and have these sort of multi-authored design projects. So over the years, we did thousands of projects, and most of them are within the United States, about 85% of them. And the designers are more equally distributed. So we have winning designers from the United States, from Europe, from Asia, from Africa. It's sort of funny because you mentioned a couple of times Richard and Daniel Susskind's book on the profession, and he gives this example of Harvard online courses having in 6 months more students than throughout the entire history. So this was also the case with Art Bazaar. We were already in 6 months perhaps the biggest, largest architectural company with most designers that was around at that point. Just to give you a quick example, this is the type of data actually clients would upload. Simple, in this case, a client from Ohio wanted to remodel their attic space. They would upload images, provide some rough sketches that the designers can plug into the software. And then designers would simply submit these type of drawings. As you all know, this is the winning designer from Colorado. But not only these sort of pretty images, but also technical drawings, so that the project owner can actually take it over to a local contractor or architect for the later phases of the project and implement the design. All these competitions are anonymous, so the designer doesn't know who the clients are, the client doesn't know who the designers are, but they have these sort of analytics pages where they can sort of get rough ideas of where the designers are located, which designers submitted, what's their degrees, occupation, country, and so on. We also, it sounds like an oxymoron, collaboration versus competition, or collaborative competitions, where actually can you form ad hoc global teams where, for example, if I cannot participate in a project, I can maybe just, for example, take the sketch of this client and create a digital a CAD drawing or something, and then offer it to people who want it. And then designers who don't want to waste their time on that can use my drawing and make me part of the team. So I could participate in multiple teams and increase also my chances of winning a competition. And then we also experimented with the iterative model, which is simply a two-phase project where the results of the first phase can be used by any other designer. So you have this multiple authored design projects, similar like in science papers where you have like 10 authors, and the location of the author sort of tells us what's the contribution to the process. And these design projects, one could also develop these type of equity divisions of the project contributions. Here's here a screenshot of a project. And the reason why I'm showing this, there is also an evaluation piece in these projects. So people can evaluate every project based on BUT function, buildability, ID, and graphics. And then it's not a purely democratic system in the sense that everybody doesn't have the same vote weight, but we sort of started weighting different people's votes in a different way. So for example, experts in this case are people who are in the top 10 or top 50 or top 100 of the Art Bazaar designer charts, who participate in a lot of competitions and won a lot. So their vote counts more than, let's say, a user that just signed up the other day. So we actually had an interesting experiment in Chicago where we had a physical jury and compared it to this digital jury, and also wrote a paper on that. But here is the problem of evaluations of regular users versus experts. As you can see, one project 32, was picked #1 by regular users, whereas by experts, it was the last of the top 12 projects. So that was the reason why we started sort of weighting the contributions. Now, let me, so this is sort of a background context. We started with crowdsourcing, but then we sort of used this sort of the data we collected, the knowledge we collected, and sought ways how we can use AI to sort of augment this or enhance crowdsourcing. And when we talk about AI, most of these projects that we're talking about, also in the sessions that we have, are about machine learning and deep learning models, but there are also other branches of AI like natural language processing, speech, like Siri and Alexa and so on, expert systems, robotics, and computer vision. But also in my case, I'm gonna talk mostly, I mean, the projects that I'm gonna show are mostly in this sort of machine learning branch of AI. So this is first idea we had was the evaluation, the aesthetic evaluation of projects to automate that. What we did was use the Art Bazaar evaluation data and train the neural network so that it can sort of evaluate any new project that is coming in. And one of the reasons why we are doing this is also because of in a lot of these projects, let's say the average submission rate is 15, but some of these projects get like 50 submissions or 100 submissions. And the project owners are often overwhelmed to really evaluate these projects in a fair and merit-based manner. So can we sort of develop a system where these projects are pre-evaluated by Art Bazaar and sort of ordered and come sort of in a ranked version where the client can then look through and decide who to pick. Also, the other reason why we were working on this, the system can also give quick feedback to the designer where when a designer uploads, let's say, a project, the system can say, okay, in terms of beauty or graphics or whatever, your point is this and that, and then the designer can decide whether to submit it or rework it and submit it later. We also used AI in predicting award amounts as a recommendation system with the quantitative data we had. So we had qualitative data with the evaluations of people, but we also have quantitative data that show, you know, how many designers submitted, how many honorable mentions were given out, how many bonuses were given, how large the conversations were in public forums about the project, and so on. So looking into the data, I mean, this, when we first started, one of the first things, or most of the calls we were getting from project owners were, you know, how much should be my award? Which is a tricky question. So we came up with a formulaic answer in the beginning. So we developed a formula based on that looked into the type of project, the size, scale, and so on, and then suggested an award. Then we switched to this recommendation algorithm, which simply looks into the history of projects and looks into 53 dimensions of the project, as I said, from how many designers have participated to the award, to how many honorable mentions were given, bonuses were given out, and so on. and then suggests an award for the type of project the client wants if they want to launch a new project. This is an interesting approach of using AI in this context was by Hostel Labs, which simply argued it's another startup out of MIT, well-funded, which who argued that, you know, from one picture we can actually predict the 3D space. So we can produce a rapid building information model out of a picture. So this was some tests from my home in Boston. So you can see it sort of properly labeled everything that was in the space from TV to couch to carpet and so on, but also predicted sort of the height and the width and some dimensions and produce a 3D model out of it. It was not accurate enough for us to utilize at ArcBazaar because even 6 inch of difference makes a huge difference if you're dealing with, let's say, a kitchen project or a bathroom project. But there are works that look into using AI in that way. Then with my co-author, we applied to a DARPA grant. And what we wanted to do here is using deep learning to train with ArcBazaar data and generate conceptual design simply. So it would do a topological data analysis of the data and identify high-performing subgraphs within the data and then composing them into new type of designs, sort of Frankensteins out of the data we had at ArcBazaar. So the vision was, you know, can we actually have AI bots that sort of also work on design and participate in crowdsourcing projects where real humans are working on. Now, in deep learning, of course, we know by now that it works super well with images, with audio, with serial Alexa and so on. We know it from web search, we know it. Labeling images, we know it with Tesla, right? Object detection and so on is super well established by now. But when we talk about architecture, it's a little bit more trickier question because over centuries, we actually developed these conventions of architectural representations. So first we have, the plan, and there are sort of evidence by archaeologues who found plans chiseled in Roman temples. So it's you can track it back to Roman antiquity. We have sections which first appeared in the 13th century. We have the perspective, as you see here in this analytique drawing, which dates back to the Renaissance, to the 15th century. And all these sort of different architectural representations or conventions of architectural representation sort of built our toolkit that we used to use, and the data we produced also on ArcBazaar are actually this type of data: plans, sections, elevations, and the like. And then the question is, how can we actually train a neural network with the data we have? And so we decided with British that we, instead of using this sort of conventional architectural representational data, we translate these into graph representations, where nodes become the program of the buildings and edges become sort of the relationship between those program elements, whether it's, are they connected through a blind wall, or do they have a door, or is there a staircase, a ramp, and so on. And we translated all the architectural data and used graph representations and trained the neural network with that information. To my real surprise, we also trained the system to evaluate projects. And so we had a training set. Half of the data was a training set and the other half was for testing. So here you see we trained the system on livability. So we scored all these buildings on livability. And then we sort of tested it with data that the system didn't see, and they came pretty close to mimicking how we evaluated the project. So the neural network's prediction, for example, for H1 was 51.2, which we gave 51. For H5, it was 67.2, where we gave 67 and so on. So it got very, very close to the way we actually evaluated these projects. And this is the reason why we then thought, we can also integrate that into sort of evaluating incoming projects for clients and rank them. So the system would simply identify these high-performing subgraphs based on functions. So it was a functional approach that we had, and then collage them together or knit them together into larger assemblies, producing this sort of Frankenstein graphs of new type of architectural compositions. Of course, this was 2017-18, so GANs were just emerging. The problem with a single neural network is that whatever you train it with, that's the outcome you get. I mean, if you train a system with, let's say, bicycles, you never get a car or something. So, but if we want to have sort of the creative leap happening, we had to look for other ways. And so we used the GAN to get us, train a GAN system and get us sort of unprecedented graphs that were not in the data set. And some of them are really not working like you have here, right? The corridor connects to a foyer, the foyer connects to a storage, the storage goes into the living room. So obviously not a functional diagram that we would use, but it was sort of a beginning of exploration, these new tools. And the idea was, of course, getting back to a three-dimensional massing model with the graph, and sort of putting a skin on the massing model, or slapping a style onto the massing model. This was our pre-AI diffusion models, but that was sort of the overall idea. And we left it there. We published our work in the International Journal of Architectural Computing. And we got sort of interested in, this again was 2018. What are others doing in this realm? I mean, it's sort of a nascent space. And so we decided to sort of put together these ontologies and see what other researchers or practicing architects or urban planners are actually doing in the world. And reached out to a lot of people. Here you see the two cover books, and maybe it's also useful for doctoral students to talk about the processes of publishing, but in essence how it works is you actually write a proposal to these publishing houses, and then they review it, they send it, I mean, if the editor likes it, they send it to external reviewers, and if it comes positive, they give you the contract to publish, and if not, they are not. I sent a proposal to Taylor and Francis to Routledge because I had published before with them. I had published after I did my doctoral degree, my dissertation with them. So this was an easy talk with them. With Elsevier, it was a little bit more difficult because they are not publishing in the architectural space. But they do cities, and so we decided to publish the city part, the AI and city in the city and urban planning and design with Elsevier, and the architecture part with Routledge. So both of the books are actually organized in the same way. So we have 4 parts. The first part is history theory, background section. The second part about tools and methods, what tools are out there, what are the new AI tools in architecture and urban planning. These are simply surveys of things. And then in the third part, we looked at how AI is used in architectural research or urban planning and city research. And in the fourth part, which was for the publishers or the reviewers, the most interesting one is how is AI actually used in practice, both in architecture and urban planning. So we had projects there, but of course, this was the beginning of studies in AI, and I'm sure right now there are many more companies and researchers out there that are also practicing AI in different ways. But this was sort of the beginning. the AI turn. I mean, Neil probably has a better definition of that. I'm not going to, talk about each individual contribution, but I want to point out actually, Kyle Steinfeld has a very nice essay for the AI in Architecture book where he talks about machine learning or AI as actor, material, and provocateur in art and design, and sort of clusters these projects based on that. And I simplified it here, and I just want to show a couple of examples within these categories. So using AI as a design generator, in this scope, actually the outcome of the AI product is instrumentalized as a design, directly as a design output. The second bucket is AI as a design tool. I mean, this is where most of the projects were actually, one could argue. This simply is integrating these AI technologies into the toolkit of architects, as simply being a new hammer that they have in the arsenal. And the third bucket was AI for design imagination. And this is simply the result of the AI output is not instrumentalized. It's not the design solution, but it's just sort of giving an idea, imagination to kickstart the design process. So for the first cluster, I put here the work of Stanislas. It's in the architecture book. And here the architect contributes indirectly. He creates the system, he or she creates the system, makes it work, and selects solutions from the output. In this scenario, the architect is impartial and conveys how the machine sees and understands space. The architect does not participate in the design process and does not make any composition, but merely acts sort of as a conductor, orchestra conductor, operating the system. So here's the master plan generated master plan by Stanislas. I would argue also Vanu's contribution. I mean, I know Xcool has many more tools that are also getting into the other clusters, but this particular project, the style gun generated buildings, are probably also falling into this category where the system is set up and there's minimal contribution by the architect. As I said, AI as a design tool is the category where most of the papers are in, and here you have simply AI used as a tool, creatively used as a tool by the architect. Kyle Steinfeld also calls this a sort of machine augmented creativity. I think there's a proper term for this. Here you have the essay by Jeffrey Landis from SpaceMaker, and he actually used SpaceMaker in a sort of future city project that me and my team are working on in Istanbul. And generated all sorts of optimal solutions for that plot of land. So it looks into optimization of noise levels, sunlight, wind, and views, and so on. So it's based on this couple of 5-6 criteria that it optimizes the entire solution. Similarly, there were other contributions in this sort of vein. This is by Reinhard Koenig, and their team developed this AMPO adjustable master planning tool, which simply does a similar thing, lays out the streets, the blocks, and the buildings, the land based on topography and other external factors like wind direction and density and so on. Also, in research, we have a lot of these utilization of AI. Here's a work by Bradley Cantrell looking into Google Street Views to obtain sort of green view rate, sky ratio, sidewalk ratios, number of pedestrians, bicycles, and so on. And below you see the project by MIT Sensible City Lab, where they developed this green view index, simply looking into how much the street is covered by greenery based on object identification of Google Street Views. Another tool, another project where AI is utilized quite often, and this is also more in line with the presentation of Phil Bernstein, where AI used in these sort of optimization processes in project management. Here you have another Boston-based startup, SmartVid, which simply looks into text, images, and video data of a construction site, and develops this risk analysis and priority lists for project managers. So another sort of interesting tool within our space of AI as a design tool. This contribution was by KPF, the architectural company, Snowaria Zhang, and this was sort of a thought experiment where you had this human AI collaboration, where humans started to sort of, as a focus group, develop a site like we used to do in urban planning. And then AI sort of fills in sort of the leftover spaces, and also not only fills them in, but also acts as a negotiator whenever one person changes something on the site. It sort of provides other solutions and better or worse solutions, so that it also acts sort of an arbitrator between the people within the focus group. It's also an interesting essay in the urban planning and design book. AI for design imagination. This was a contribution by Sasaki Architects, and they trained a neural network based on Barcelona satellite images, and then used it as sort of a style transfer for new lots. Like in this case, they picked a lot in Cambridge, in Massachusetts. And so they get to sort of quick ideas about what this, it's almost like a style transfer, right? What Barcelona, a city block would mean in a new context in Boston. But this, I mean, city planners do that quite often, where they use, for example, the square of San Marco and put it on a site they're developing, just to see the proportions and how the size and scale and so on, and understand it better. So, and there are, as I said, there are many more articles within the books, and I urge everybody to purchase these books and make me rich. I know you don't get rich with academic books, but yeah. So if we have a little bit of time, I just want to show a couple of more projects that me and my students were doing. So one is this called the Dhaka Project that one of my doctoral students is continuing doing, translating the graph into a massing model. And then, and how he does that, he uses another GAN engine to create these floor plans, and uses Blender to stack them three-dimensionally, creating these massing models. And then using AI diffusion models, image-to-image AI diffusion models to create different styles, slapping different styles onto the massing model. Simply, it's sort of the reverse of what we have seen, right? Taking a mid-journey image and reverse engineering. But in this case, we actually have a GAN-generated graph that we turn into a massing model that we put some style on it. And here you see actually he used modern house, parametric house, Zahadid, and even tried some neoclassical and Victorian styles, which surprisingly turned out not that bad in terms of the diffusion models. He also tried to take the outcome from one diffusion model into another one and see much more detail developed. Here you see the freeway ML diffusion model put into the Dream Studio and getting much more clear and nice results. In a seminar I'm giving on the future city, I asked students a 1-week exercise to use these different diffusion models and experiment with prompts, and there were some really exciting results about some really fantastic future visions, I would say. Here, one underwater, putting a city underwater or in the air, why not? I mean, they were experimenting and getting quite some interesting results. This was a landscape architectural student who wanted to see albedo of buildings with greenery, and it resulted in quite some exciting discussion topics about urban planning, urban organization, city organization, and characteristics of these developments. It's really sort of a Kickstarter design imaginator in a way for this discussion. Here, another students used Midjourney to develop a scheme, and then used it in DALL-E to expand on it with different prompts for different type of programmatic features of the city, which I thought was also quite an interesting approach to deal with that topic. Now, as part of ArtBazaar, we actually worked on a community app called the Space App, and we also integrated a diffusion model for lay people, for project owners who can just upload a picture and, you know, lay the area that they want to have redesigned and put the prompt in it. And this we launched last week, and it works quite well. So people can just, you know, type in what they want, and like DALL-E, it produces these type of different options. And it also, again, is sort of lowering the barriers between clients and designers, and starting sort of a discussion with them with these type of tools. I mean, that was sort of the ambition that we had with the Space App, so they can start using these type of sketches and ideas to kickstart the conversation. And in the end, I want to show another work which we are doing with another doctoral student called WasteWorks. And here we are collaborating with a local artist who uses waste to create this sort of fascinating portrait images. And and the student was working on zero waste, on an article on zero waste, and there are about 2 billion tons of waste around the globe, and a third of it is never actually recycled. So this was sort of an interesting idea of how can we sort of work with this artist and maybe develop an automated system that can use waste and create these beautiful artworks. And for this reason, we used a robot that can do, I mean, eventually computer vision, and can sort of identify objects, waste material based on color and type and so on. And these type of object identification projects are actually I mean, out there for some years now. And this is a company called Tarsins, a Turkish company that does yield estimations on farms, and quite accurately. So it tells you how much yield you simply have in the farm, and so the farmer can sort of plan accordingly. This is the robot we purchased. and simply it's 140 by 140 canvas. And for now, it's just doing pick and place, but we just got it 2-3 days ago. So we are sort of in the baby steps right now. As you can see, it is able to move things around, but we need to speed it up and train it more to do different type of translations, movements, rotations, stretching, and eventually we also want to use it for other purposes. Like the school has a bigger KUKA robot arm that they are using for 3D printing. And we are using the smaller robot arm for this type of project. So this is, let me end here. I don't know how much I was over my time.
Don't worry, it was fascinating. We was a little long, but never mind. But thank you so much, Imdat. I think there's a lot of stuff there for that's kind of that's provocative in terms of discussion and things. So let's move straight on to Silvio. I think Silvio, welcome. It's great to see you and great to hear your voice eventually. Thank you.
Apologies, everyone. Can you hear me?
We
Yeah,
can hear you,
we
can't see anything yet.
So there was the perfect moment for my Zoom to crash. So apologies to that.
Okay.
You see my presentation?
No, not yet. It says it has started a screen sharing, but hasn't got any more. No, okay. Yeah, now we can see, but actually if you just go, we can see the PowerPoint in the background. Let me just click off that. Okay, good. Fantastic.
We're good to go?
Yeah,
you see it?
Great, thanks.
Thank you. Apologies for that. Thank you again for inviting me here. And I will. So my presentation is divided in 3 parts. The first one, I will try to explain a little bit the kind of theoretical or informational coordinates for this work. In the second part, I will give you a little bit of glimpse of the book. In the third part, I will just conclude with some kind of contextual information about what we do in our research team, but also how I see the future of machine learning and cities. And so the first part is really why machine learning and why now, I suppose. And more and more it became apparent in the past few years that obviously machine learning and artificial intelligence has been used extensively and increasingly in many fields of design. And so, again, as Neil said a few presentations ago, I think what we see here, we talk about here today, is something that started 3, 4, 5 years ago. And sometimes there is this problem of time delay in dealing with this. But so 5 years ago, we start working on this proposal for this book, and then so artificial intelligence is a large area of research where scientists are trying to design intelligent systems that are able to make decisions independently. So in order to decide autonomously, a machine needs to learn and create new links between data through inference, association, things like correlations. and classification. So in other words, trying to establish relationship among type of data within the same data set. Computers need to learn from existing data, and in order to predict new data, as machine learning should do, they should be able to compute best solutions based on the input that they will give to the computer. So machine learning is the combination of several models and techniques that are based on probability, theory, statistics, data science, and all kind of on the underpinning level on applied mathematics. And so, given enough training data, a computer, as we all know, can learn to recognize patterns in numbers and shapes in our data sets, and as well as generating some sort of understanding of what the trends and the patterns are within the data. And so the idea of this book is, by having a clearer and deeper understanding of all these models and techniques, designers can directly see what determines a choice in an intelligent system. So in other words, the reason for this book was actually trying to show to designers and architects the very basics of all these models and techniques. So not only the book shows a variety of models and approaches to machine learning as it is, but also goes very deep into the mathematical side of all these models, and trying to explain, really, especially in the first 2 or 3 sections of the book, where these all come from mathematically and again statistically. And so the management and control of cities are increasingly characterized by a vast infrastructure of interconnected devices, as we all know. And this requires architects, urban designers, and planners to use and design tools that are intelligent in order to handle the growing urban complexity. And complexity is one of the kind of underpinning word of this whole world. The book starts from the thesis that cities are increasing dramatically in complexity for many reasons, and therefore, because we have to deal with this complexity with a lot of data, a lot of information that are not only growing in number but also growing in type of sophistication, and therefore, I suppose, oversimplifying the thesis, the only way to deal with all this complexity is to use kind of computational power to deal with that. So in this particular case, to use things like machine learning or AI. And so machine learning can be increasingly considered the backbone of urban intelligent systems. So any system that is controlled by interconnected machines where a degree of artificial intelligence is present. So in other words, we all talk about AI, but what I suppose the main point is that we use machine learning as a sort of infrastructure or understructure in order for us to be able to deal with all the AI systems. And again, underneath the ML, the machine learning system, as I said, we consider that the main part is the applied mathematics, or the kind of statistical approaches to deal with that. So moving on, what I want to do now is to quickly go through a number of kind of key coordinates that are the kind of the framework of this book. The first one is machine learning between routines and wonder. And so by this I mean that recently machine learning has been increasingly used in many scientific fields, as we all know, and in order for all of us to be able to deal with this complexity, but also to manage complex decision processes. So we distinguish in the book in the kind of 2 main parties to this. So on the one hand, there are those who use and have been using for many years actually machine learning routinely, so as a kind of part of their daily job. So you can imagine people in computer science, in finance, in physics, in astronomy, medical science, statistics, all these professional figures, they have been using machine learning for many years now, and for them it's just a normal part of their routine. And so the kind of the left part of the screen you see there is basically exemplifying this process of just normally using machine learning as part of your job. And these individuals have generally a solid understanding of both the potentialities, but also the limitations of this form of automation. So they know exactly when to use it, how to use it, and where this all starts and is all finished. And so these users employ machine learning as part of the normal skill set to solve normal problems, calculating trends, forecasting weather, and things like that. On the other hand, we have another group of people who have limited understanding of machine learning and how it might actually work. But for those people, automation processes is where machines are able to make or to take decisions independently. And so this kind of group of people is depicted by this person on the right-hand side. And so these people often are kind of mesmerized by what machine learning can do or could do. And so decisions in this particular case are devolved to programmed automated systems. And so for this kind of second group of people, computers have some sort of responsibility and some sort of agency in deciding things. Whether for the people on the first group, if the people on the left, they know exactly that computers have no agency at all. It's just your software is as good as you programmed it. So if your software, as we see in a minute, but if your software is not working properly, it's probably because you made some mistake in your code or something like that. And so computers have no responsibility. Certainly not in a social or ethical or legal terms, not ideologically or politically. They have intent. They have no regrets and no guilt when they process all the machine learning routines that they do. And so from this perspective, it's not difficult to associate deciding machines from the second group with dystopian narratives where computers will eventually replace our jobs. And then they are able to make ruthless decisions without considering the social or human context in which they are made, or in the most pessimistic vision of this narrative, machines replacing humans, as machines at a certain point will deem human species to be obsolete. We all know some sort of science fiction or some sort of film or TV series that depicts this particularly well. And so between these two extreme positions, the very experts who see routine in a kind of very cynical way, they just use it for what it is, and the people who are actually amazed every time they see some sort of machine learning happening. Between these two poles, my argument is that lies the majority of people, pretty much all of us, I suppose, where we just use machine learning sometimes in a conscious way, so we know what we're doing, and sometimes in a very unconscious way. One of the example of the unconscious way is where your email inbox or your email software will actually recognize automatically spam from a non-spam email, and therefore you simply see your kind of clean inbox because some of the machine learning has been done for you in the background and things like that. And so what I want to do now, I want to share with you a little video that we created a few years ago to actually represent this kind of dystopian view for machine learning. so the idea for this little project was to try to explain to everyone, or to people in general, how a computer will actually be able to recognize a public space as a kind of cafeteria type of space, based on the sensing devices that particular computer can access to, so microphones or CCTV cameras and stuff like that. And so we try to show the process of perceiving bits of information, put them all together to try to kind of profile people using, again, languages, using information retrieved from social media and available online, so to create a profile of a person, and on that basis kind of rank that person in terms of productivity and, you know, how useful that person could be, and things like that. So it was a little bit of a kind of a fun project to do that, which the project's been exhibited in Australia in 2 or 3 museums, which was quite an interesting experience for us. But so again, that is kind of hopefully kind of help set the tone to understand why we want to, with this book, we wanted to explain a little bit more what goes behind the scene of things like that. And so another thing I really want to say in this book is, and you know, it's quite clear throughout all chapters, is that machine learning is nothing new. You know, it might be new now to many people simply because it's becoming mainstream, but actually, you know, people have been using these techniques and working on this space since the 50s and 70s, and many before. You know, one of the first traces is probably Charles Babbage, that, you know, and Ada Lovelace, as we all know, about this kind of first type of computer or autonomous system that tries to kind of calculate things that humans cannot, in simple terms. And so let me just go against the slideshow, apologies. Yeah. And so yeah. So one of the things I want to say is, obviously, yeah. So when I say machine learning is not new, for some of us who can kind of recognize this, sometimes I'm using kind of memes in this presentation just to keep it a little bit lively. But as you can see, the first one that we say is just, you know, behind machine learning, there seems this very obscure concept, this very kind of black box approach where you put data in and something happens and then it spits the data out or kind of new information out. But actually, most of the time, you know, again, as I said, there is a lot of statistics going on, a lot of modeling inside, or it, you know, down to simply sometimes, you know, if inside AI is something like, you know, a lot of kind of conditional statements that go into that. And my favorite, one of my favorite is this one. Probably you're familiar with this, but it's sometimes I use this with my students to underline the fact that data science and, you know, also machine learning is actually really statistics in disguise, as it were. And so the other point I want to make is machine learning is about correlation. Computers are able to learn by finding relationships between data, as I was saying. At the most basic level, a learning algorithm, kind of the very strict-based version of machine learning, is a function through which a computer can calculate and therefore predict the value of a variable or multiple variables based on the given condition. So you have an equation and you have different variables, and then you have a way to calculate or to predict or to estimate the value of those variables with certain precision. This is the case, for example, of linear regression, where a function needs to determine a line that describes the data points in a kind of distribution, something like that. or on a more sophisticated level, a machine learning algorithm is able to infer the rules that underpin a behavior of a given phenomenon. So on the very basic level, you got a number of a set of data. They are all distributed in space, in this case X, Y, and then you try to find I suppose a line that describes the distance of these points from an imaginary line. On the that's kind of the very basic version. The more sophisticated one is where we try to predict the rules that will determine and underpin a sort of behavior in a more complex system. Another thing I always mention, and it's quite clear in the book, is the fact that obviously your algorithm is as good as, or your machine learning system is as good as the data that you use to kind of feed them. And so sometimes, again, especially for the second group I mentioned, sometimes there's big blame and shame about they're using a bias algorithm and stuff like that. But actually, I think I suppose you better try to put an emphasis on the type of data that you're including. And I mean, I go back to Babbage, who in 1864, it was one of the, as far as I understand, one of the first one using, I suppose, this type of expression, where he said, if you put into the machine wrong figures, will the right answer come out? So Babbage, in the 19th century, was already trying to understanding the importance of inputting data and to achieve the desired results. Description and prediction. The data that we use in machine learning can be thought as an abstraction of a given real phenomenon. And so the first thing that we all do when we need to approach a design problem, for instance, is trying to understand the problem in a way that can be processed by algorithms. And so obviously there is an analytical phase where you try to do an analysis. So you try to break down the problem into elements that can be measured and whose relationship can be established. And therefore, after that, you have to find a way to put together all these elements into a convincing and cohesive story, as it were. So what we call modeling. So you're trying to put all these factors that you identify as a part of the problem in a proportionate way, in such a way that you actually get the outcome that you want. So you do the analysis, then you create the modeling. And so, in other words, you have to try to create a description of the problem in a way that can be not only computed by machines, but also in a way that makes sense for the problem you're trying to resolve. And obviously is in this translation between the problem and what can be computed that most of us will find problems, and sometimes your design can become a little bit clunky. And that's when you have this kind of, in a funny way, you have this discrepancy between what is expected and what you actually achieve at the end. And then, in a more kind of tutorial way, it's what you expect at a certain point and what you get at the end. Probably one of the last points I want to make is that not all training is learning. And by meaning this, that obviously we all know that with machine learning you have to use a lot of data points in order to train the model, and then I suppose the more data you use, the more the chances are for your model to be accurate. I mean, that is true in a sense, but also as you get a little more familiar with the system, you understand the concept of things like overfitting or underfitting. And it's when you have to, what I'm trying to say here is that you have to find the right balance between the training data that you're using and the problem you want to resolve or approach. And so the system is quite complex, but it's also in the book there are 3 or 4 chapters that address exactly this point of underfitting and overfitting and how to do it. And so probably my last point here is about accountability and responsibility. As touched up on this just 5 minutes ago. Sometimes, and we all know from the news that there is a lot of blame against, a discriminatory algorithm or biased AI system. But actually, if you dig down into how this particular system works or the algorithm works, most of the time there is no bias at all. Or actually, to be more precise, bias is part of the process. And so there is a lovely article on Medium. One of these contributors tried to explain how you can actually escape bias. So if you have two categories of people in your experiment, and then you're trying to be as much as unbiased as possible, you will always, for one reason or another, almost favor one group over the other. And so if you try to put the emphasis on one group, then you disadvantage the other. So there is no way to be completely unbiased in what you do. And so I suppose one of the main points of the book is, and there is a big section, I suppose the final section of the book is all dedicated to this idea of accountability and responsibility. So shifting away the responsibility from this kind of biased AI system to the people who actually use them and the type of data they use. And all that. And obviously there are examples and methods to try to combat a little bit this bias there. And so finally, my final point on this part is that one of the advice that runs through the book is that machine learning is something that you should try to know as much as you can. And you also, my personal advice will be to try to consider it as a sort of aid to your design, sort of good colleague, as I call it in the book. And so as such, you have to try to understand how it works. Even if you're working with a person in the office, you want to know this person, you want to know what this person is good at or is less good at, what are the pinch points, the pressure point of this person, and in other words, how to try to work in the best possible way with this person. And so with machine learning, it's exactly the same. So you have to kind of be familiar with this system and totally understand what you can do and what you cannot do, and when to ask its help and when not to ask its help, and all that. And so moving on to the second part, I'm trying to go quite quickly now. This last book that, as Neil said, was published last July, is actually coming from a long journey of trying to work with urban spaces and try to understand the impact of digital technologies and kind of synthetic intelligence, artificial intelligence into and into design and for the city. Perhaps I want to mention this book, that it's kind of between 2018 and 19. I suppose the predecessor of this machine learning in the city was this book called Big Data, Code and Discrete City, where I tried to explain how cities can be almost discretized into something that is understandable by computers. So how, it's all narrative of how computer will understand cities, and therefore how designers should represent cities in a way that can be processed by computers. And so we go to the book. The book is divided in 5 sections. The first one is pretty much dedicated to all this idea of, quite glad that Neil talked about emergency, because this first section it's all about urban complexity and the emergence of patterns and things that they're actually not scripted at all, or not perhaps designed at all within the city, but nevertheless they just emerge. And so because the emergence is so complex, then actually you need tools to be able to cope with this complexity. The second section is we try to explain that how computers work. And the third section, how machines actually are able to learn, process in order to kind of render, to return new information or trends or things like that. And then the fourth section, which is the biggest in the book, is it's dedicated to actually how we apply as designers all this knowledge that is described in the first 3 sections to the kind of urban scale. And finally, as I was saying before, the final section is all about try to explain or reflect rather about who's responsible for what and what's the agency of computers within these processes. And so this is kind of the table of contents. It's how the book looks like. Each section comprises the black text, which are the kind of theoretical informational chapters, and then the blue one are kind of case studies and projects. They kind of try to demonstrate how this information is actually applied into practice, and so you will perhaps recognize a lot of very familiar names there, which is great. Yeah, and so you see the 5 sections here. So I was saying the 4th section is the biggest one with all the applications to the kind of urban scale. And just to give you a little bit of timeline of this book, perhaps you might find it interesting. I started the discussion for this book with Wiley in September 19. That led to the full proposal in January 2020, and then by end of February 2020, I received 6 positive reviews, which was great. To be honest with you, I was always expecting a little bit less, but it was great. And then we signed the contract in March 2020, and then submitted the whole manuscript in June 2021. And then the book was released last July. And so just to give you a little bit of some numbers, we all love numbers. There are 146 contributors in the book. There are, for those who edit books, you all know that because 146, more or less, you need 146 document signed approvals of each contributor that they are happy with the contents be published and all that. And so I counted 682 emails in my inbox dedicated to this project, roughly about 700 hours of work across pretty much 2 years. The book is thicker than expected initially, 642 pages, and there are roughly 28,890 lines of text in the book. And so when I was working on this book, these were among many other books that were on my desk, that I was not only looking for inspiration, but also be aware of the contents and try to kind of merge together in a kind of significant way the contents. And when the book came out, these were kind of pretty much the competitors, but pretty much the books that accompanied my book on the same shelf, as it were, with a digital shelf or physical shelf. And obviously I've got Imdat's 2 books there, Neil's book there as well. So I'm glad that we're all presenting kind of within the series pretty much all this book together, which is great. I think we're representing kind of the same digital shelf. So this is the book. That's me flicking through the book quite quickly, just to let you know kind of how it looks like, it feels like. Hopefully you can appreciate that. And so inside you can see there are it's all black and white, reckoned because of the length of the book, but you will see it's a combination of a lot of text, graphs, diagrams. You will see equations, applications to the city, curves. There are a lot of curves there, yeah. So hopefully it gives you a kind of an overall idea of how the book looks like, and yeah. I just go quickly. You don't need to see all this 2 minutes long, but yeah. And so the final part of my presentation is really, I want to leave you with kind of a little bit of context of what we do in our research team. We use computational tools that we apply mainly to cities. but with a focus on a kind of zero carbon and climate change and carbon footprint and things like that. And I'm not talking about our projects, but I just want to give you a little quick taste of how our kind of project folder looks like. So you've got a lot of computer vision there, a lot of building performances, clustering, machine learning, a lot of generative design applied, a lot of app design, and yeah. And so that will give you a little bit of flavor of our work and where we come from as a group. And so that's my final slide. I really want to leave all of you with kind of this 5 points here that perhaps can help with the discussion. And so having worked on this kind of space for quite some time, but also I've been trying to kind of coalesce everything into one book, working with very, very interesting people for this book. Really, I suppose the message that I have is really that, and then I say this very clearly in the introduction to the book, is that more and more designers needs to become more familiar with, or go back to kind of some sort of familiarity with math, statistics, and computer science in general. I think it's so easy now to apply models that are out there, kind of ready for us to use, but the more we understand a little bit the mechanics that underpins all this, the better for us, the better we are kind of using these tools in a kind of more sensible way. And so there is this tendency to move towards a little bit more kind of science part of architecture rather than kind of the art side of architecture and the kind of history. Which is, I reckon, is a kind of a sort of national, international push towards science everywhere across the world, I guess, simply because of I suppose, the ubiquity of artificial intelligence, and therefore architecture is almost responding to this with our own, I suppose, version of cities. And then again, and there are new models and new tools readily available every day, pretty much. And this was quite clearly explained by Matthias Del Campo in a discussion, I think it was last week or 2 weeks ago. It was very, very interesting to see that, it's like Imdat explained with GAN, you start working with one model, and then, the minute you're ready to publish the work that you've done with that model, and the 2 or 3 models have been published, and so you need time to kind of keep up with all this, which is great, but also quite intense for all of us. And in all these, designers are trying to reconfigure their own profession. We are all trying to kind of understand what our role is. Are we scientists? Are we kind of urban scientists? Are we what is a designer? And that's, I suppose, everyone who teaches architectural design in some school will have these questions, and will need to answer this question to the students at a certain point. And then again, I would just conclude with a final point that I think Neil said this at the very beginning of the series, that there is very exciting times to be an architect and to be a designer, to be in this space, simply because we are kind of on the verge of something very new, very revolutionary, and then probably there is no better time to be a designer. And so with that, I think I will close it here.
Thanks, Silvio. That's yeah. I was thinking about your comment there that the time it takes to publish. I mean, I think most of these books are completely out of date because diffusion models, in terms of the illustration, the diffusion models have come along and are so much more advanced in some way than the GANs of the past. So we've now got moving into the kind of question time. The presentations have been great, but we actually don't have so much time. But anyway, let's try and fit in some questions. If anyone's got any questions who's following on YouTube, please could you send them in on the chat, and also in the Zoom correspondence here, the group on the Zoom as well. I just want to make I've got a couple of questions. I want to make one correction to myself. I mentioned that 2009, the iPhone was launched. I meant that Uber was launched in 2009. Anyway, so I've got one. Maybe just kick things off. I've got one question for Imdat and one question for Silvio. I must say it's great to bring you all together. I've only ever communicated on emails with you, so to hear your voices, and I think the kind of immediate feedback you get from these kind of sessions, I think, is incredible, because there is a kind of global brain in operation where you bring people together in a very immediate way, can kind of brainstorm certain kind of questions. So anyway, I wanted to just Imdat, first of all, I mean, fantastic presentation, and I was kind of thinking of when you were crowdsourcing, you were talking about crowdsourcing in many ways. That's kind of what the diffusion models do in some way. They're sourcing anyway from a multiplicity of things. But they were kind of, well, I guess that there are two factors that have always hit me in terms of what the research, what the materials we found in this process. And one was the kind of the concept that actually maybe not humans don't necessarily have the best answer. I mean, the idea of crowdsourcing assumes that humans have the best answer. But I think the comment that I came across from Harvard Hoagland from Spacemaker when we had a discussion about it, the fact that AI was able to come up with solutions that no one would have thought about, which is kind of the move 37 of game 2, as it were, of AlphaGo applied to architecture. That's one of the kind of comments which, you know, maybe that disrupts that model a bit, to say that crowdsourcing is maybe not enough, and then maybe AI sourcing maybe needs to come in. But the other one, which is really, I think, fascinating, and it kind of connects in many ways to the Susskind's book, was a comment that Wan Yu-he made in our discussion about the Office of the Future, where she commented that actually XCool has been commissioned to evaluate competition entries. Now, that is absolutely fascinating, because the implication of that is if you're using it to evaluate things, and not just in terms of kind of aesthetics, but obviously performance questions. And I guess the most important question I would say would be cost. You know, that's the kind of the issue that I think becomes super important, because once you can evaluate things using AI, it means you can generate things that are conforming automatically to those requirements, which to my mind, that's the absolute game changer. And I guess that just from my own personal background, I wrote a slightly, I wouldn't say conservative, but a sort of a bit of a kind of negative book about aesthetics years ago, and aesthetics of architecture, where I was talking about how architects were always obsessed with appearances, with representation and so on, but the client was interested in something completely different. You know, and what gets left out is often the question about the financial side of things. And as a profession, as a discipline, we never talk about that. You know, if you any book on history, you won't see any reference to the cost, apart from the cost of the book on the back cover. And I remember when I was studying at Cambridge, just down the road from where Silvio is now, my professor, Sandy Wilson, would have an argument for whenever his building went over cost, and every time it went over cost, right? And he would quote this famous case from history. I probably don't know about it, but it's an example of Pope Pius II, who commissioned Bernardo Rossolino to do a building for Pienza, and he went way over budget. And so the Pope summons Rossolino, and you know, this guy is kind of quaking in his boots because he's thinking it's the Pope, and the Pope says to him, "Well, you know, you lied to me about the cost," and he said, "But I'm glad you did, because if you told me the true cost, I would never have done this building. And as it is, we have one of the greatest buildings that ever produced." Well, I would disagree maybe with that, but so Sandy Wilson would say, "Well, don't worry about the cost. We've got this kind of fundamental, you know, it is a beautiful building." But the cost is going to be the fundamental requirement. I think going back to the Susskind's, and I think the Susskind's book is really something very, very important about the profession. You know, what is you know, particularly the RIBA and the AIA and all those other organizations, these so-called gatekeepers, as he puts it, to the profession, and what is going to be guaranteeing their existence in the future? That's, to my mind, it's a super important question. I'm not quite sure. I would love to know where that 10% of all buildings are done by architects. The typical one is 5%, but I could never find where the source was. It's become kind of a popular myth. It's 5%, 10%, whatever. But the point is, they haven't done much to defend the profession so far. And my question would be, well, actually, if you think through the implications of what Wan Yu's kind of saying, what does it mean in terms of kind of buildings being able to quantify performance? What does it mean in terms of the profession, in terms of the AIA, in terms of the RIBA, and so on? Because if you think about it, I mean, I guess the way that it's been operating in the past, you are examined. You go through this process of licensing, and I'm licensed in the UK. I haven't used it, but I've used that process basically is to see if you can prove yourself to be good enough, right? And you can once you've passed the test, then you're licensed and so on and so on. But the reality, it would seem to me, is that if AI is able to evaluate everything in the future, we won't need that. We won't need to have any of these organizations, and effectively, we will be evaluated on the performance of our designs. Now, that is not good news for the RIBA or the AIA. In fact, frankly, bots don't need to belong to these practices. So, so effectively, I think the first ones to disappear are going to be the AI and the RIBA. That's my prediction about this. But I do think that the key question is cost. And I think this is where the Suskins also are kind of pinpointing things. Who cares in the end? Who cares? It's going to be the cost that's going to be determine everything. And I think that from the point of view of aesthetics, or of the kind of representational world in which architects are locked, the only area I think where we're going to survive from that point of view is the kind of logic of branding. In other words, if you've got I think from that point of view, the Zaha Hadid architects is a bit like Gucci or something like that. You're going to pay for an image, but because it's a branded image, it's an image that might give you a certain kudos. And you have two logics. One is the logic where, frankly, most people want the cheapest possible, and therefore AI can tell you that. But then there's the other people who don't care about money because branding is a question about conspicuous consumption. You're carrying your Gucci bag not because you want to show that you've saved money. You're carrying it to show that you don't care about money, and so on. So I just wanted to kind of throw that out there as a kind of comment that is not the logical consequence of what you've been working at over the years. It's going to be coming into eventually a kind of evaluation system whereby AI is going to basically be evaluating everything, and which I think Silvio alluded to as well. And I think that cost is probably going to be the key constraint, although I imagine also environmental kind of performance questions and structural performance questions and so on are going to be key. So sorry for that long-winded question, but I just wanted to kind of throw that at you because I think the seeds of something else are contained in what you've been doing research on over time. You're muted.
Yes, I was muted. Sorry. Yes, I think you're absolutely right. I mean, I was really fascinated when we did this training and this testing of the neural network, when it sort of brought back the points, the grades we gave to the project almost accurately, and that was one of these wonder moments that. For me, at least, that Silvio was showing in one of his slides, right? But I think all these sort of what you're mentioning about value for the sort of quantitative aspects of the building industry, I think there's no question in my mind that the system should be able to do that. I mean, she was actually showing in one of the sessions a tool that they developed where you design and all this sort of mechanical HVAC systems, plumbing, and sort of adjusts with it. So I assume while you're designing, you already get that feedback about cost and so on, and other sort of quantitative aspects. What I'm personally interested in as a designer are these sort of qualitative aspects, the aesthetics. When is a project actually good or bad? And that's in Art Bazaar, it's a little bit of an interesting question because we are dealing with regular people, not experts most of the time, who evaluate projects. And like in Liam Trier's sketch, right? They love their Palladian windows and Victorian houses, and and the danger also with AI in a way, and with Art Bazaar, is this danger of inbreeding, right? That it's sort of, I'm delivering what the client wants, hence how does the profession sort of evolve and develop? Where is that? I mean, we talk about AI being biased to the data and so on, but how does that lead forward, the avant-garde, the progressive moments of architecture happen? And I think those are the interesting parts I'm interested in. And, with the evaluation process, we had a very practical problem, the problem of being overwhelmed. And this is actually in regular competitions, it's much more common. For example, for the Opera building in Paris, there were like 800 submissions or so, or 750 submissions. I mean, no matter how the jury is well-intended and merit-based and fair and whatnot, it's just humanly not possible to evaluate these projects, and they apparently put that on panels and lined it on the street for 3 miles. You know, it's like, how can you even judge those type of projects in a fair and merit-based manner? And in ArcBazaar, we have sometimes similar issues. So can AI actually help to order a stack based on the judgment of AI? But again, there is also this danger: what is good, what is bad. I mean, if it's constantly suggests that Victorian houses are the best solutions, then, you know, then people also will pick those type of projects. So the challenge is, how do, as architects, how do we take this, the public forward? In a way, these diffusion models are sort of a blessing where quickly an architect can also use them and show the potential to project owners, right? I mean, yes, you want a Victorian house, but here, you know, this is how a parametric or Zahari design might look like. And they might like it, you know, but traditionally you cannot do that because it's just too time consuming and too costly and etc. So, and I don't have any problem with AIA being dismantled that way. I mean, they actually sued us when we first started ArcBazaar. We got this sort of very angry tweet saying this is the worst thing that happened to architecture since the internet started. And then we got sued by them based on some AI policies, I think. But we met with the person they hired as a lawyer, who was a lawyer at the, or was also an architecture faculty at the GSD. And a friend of my doctoral advisor, so we had a good time talking about these things, and it turned out, you know, all okay. But their concerns was about price fixing, about can we call this architectural, is it architectural design, or, you know, and there were, I mean, I think the other problem why AIA might hit the barriers is also the issue that I mentioned about scalability. You know, if you have 1 million people wanting design and you have 10,000 architects, how can you even deliver that? So I think that there needs to, what the Suskins were talking about, these experts people, right? That can sort of, I mean, actually one of my investors is now working on a startup called skills.com or something, where they try to train regular people on not professional work, but because there's also a shortage of contractors. I mean, in Boston, if you try to find a contractor, there is no one out there for 3-4 months. So can you actually leverage technology to get people involved in these type of projects? And maybe that also goes into the profession, like the Suskins were sort of mentioning. So I mean, it's an interesting time where all these sort of shifts are happening and the power structures are changing, and these licensing things don't mean that much anymore. It's I mean, you gave the example of Uber, right? I mean, for example, once you have a technology that can show you the directions and stuff, why do you need a license for cab drivers to know all the streets in their minds, right? And it opened up this flood of potential cab drivers. In the same way, you know, electric autonomous cars, right? Once they're out, people argue you're not allowed to drive anymore because, you know, I mean, it could be that AI produced such great architecture that architects are not allowed to design anymore, you know. It could be also that. So there are a lot of these sort of interesting changes happening. I'm very happy to be in that time, like Silvio's last slide, right? To be an architect at this time of change.
Maybe I can just pick up on something on Silvio's point. I guess there's a fine line between exciting and terrifying. I guess that would be the point that I would make. And I just wanted to say, well, first of all, just before I just say anything, I just wanted to kind of clarify for those that are not familiar, because we use 3 different terms today: AI, machine learning, and deep learning. And I guess the kind of the point being that you should see these as nested inside each other. Deep learning is a very recent phenomenon that came around, I don't know, 2006-ish. It sort of took off, and it was to do with technological advances. In other words, you could now computing power, data available, the use of the cloud, and so on. And that really was a transition. So while we had machine learning before, it was nothing like what we can do now. It's a bit like the comparison I make is between the very first car we get and a kind of Tesla car. Certainly people say this to me, and John Fraser, well, we were doing machine learning back in the 60s. Well, sure, but it's nothing like what's happening now. But AI is the broader category. And I, maybe for rightly or wrongly, I think when I use AI, I'm thinking about deep learning, but, just to make clear those categories. But I just want to pick up on the kind of the terrifying thing of things, because I got a message this morning from Sasha Lubetkin, who was the daughter of Bertolt Lubetkin, and I put out those images on Instagram. That's where everyone's pushing their AI-generated, diffusion platform-generated material. And Sasha said, terrifying. It absolutely is terrifying. But the funny thing was, I had tried before with the word dystopian in my prompt, and this I didn't put the word dystopian, but what it produces is absolutely terrifying. I mean, don't get me wrong, it is. But I mean, I'm a great fan of Blade Runner, so I quite like the terrifying, as it were. But anyway, there is something terrifying about this, and I'm not just simply the fact that actually we might lose our jobs and so on. But I want to pick up on this because it's especially in relation to what Silvio was saying. I want to say also Babbage. I've got to say, when I first came across, when I was in Cambridge, not so far from where you are, I was working on Alberti years ago, back in the 80s, and I was sitting in the computer science department above the Babbage Lecture Theatre in Cambridge. And what was interesting about this was that, when we were doing the Alberti translation, well, I did the translation, but Joseph gave me a book and said, listen, we will do it in this style, right? And this was kind of postmodernism, right? The 80s and things. Actually, what happened was something completely different. And I was sitting up there, perched on a stool in this computer lab, surrounded by these incredible geeks who had no social skills, but were able to do the most astonishing things on the computer. And what I began to discover, actually, forget style, I mean, that was postmodern, what you were able to do when you were working on a computer, when you could revise a text again and again and again, and I would say every single sentence in the Alberti translation was revised 25 times, something comes out which is much more pithy, more precise as a language. And I began to realize then, it was the early days of CAD and so on, but I began to realize that really it's about the process, not about the representation, not about style. It's about the process and what this process can do for you. But anyway, I want to get to the dystopian side of things, because I thought that was really, I was really taken by your little video, which is a kind of, a fake video, but nonetheless, it was very telling about identifying that woman out there. And, I think in a sense, my view is this is a tool and it has no inherent like good or evil. A kitchen knife, I'd always say, you can cut vegetables up or you can murder someone. So it's not the question of the tool itself, it's the question of how it's being used, and who uses it for what. And we know that potentially for surveillance, there can be quite challenging. And I won't say which country, but there are countries where you can go jaywalking, and by the time you've crossed the road, you've already got some money docked off your bank account because it's all in this thing. And the question ultimately is really, in the future, you wonder whether there's going to be ever any escape from this kind of system that will know and understand everything. And we kind of brought up this slightly romantic idea from the movies about how life can be, and in the old days, there were bank robbers, right? And whoever gets away with any crime these days, they can always get surveillance there. They can, and my view is kind of like, well, it's almost like that we have two options, and one is the kind of to behave. I mean, you got to fit into this sort of thing, or try to escape. But I can't see that there's any escape right now. I mean, well, at the moment there is. I mean, for example, let's say people will ask for cash rather than credit card because they know they haven't got to declare it and so on. But in the future, I don't think cash is going to be there at all. We're going to be locked into this system. And how do you operate? How do you is there a way? Is there any escape, or do you have to conform? Do you have to become like a saint or something because it's going to know what you're doing? So I just wanted to throw that out there because I thought that was the really provocative kind of comment out there that there is a dark side to all this. And I just finished off by saying that since Silvio is from Italy, a country that I was through Alberti, was brought up with the dark side. And I'm doing 2 books, one with a white cover that's already published, and also one with a black cover about the dark side of AI, the evil side, the devil. And all I know is about it. Well, I've done a lot of research on it already, but my finishing comment is going to be, the profession of architecture, which began with Alberti, because he was the person who defined the architect as being in charge, and increasingly already in the UK, the architect isn't in charge. I mean, it's mainly developers who are in charge. The architect works with the developer. And so we already are struggling. And AI, to my mind, could be that final nail in the coffin. Because certainly in Imdat's model, of the interior, well, why do they have to go to an architect? They can already do it themselves. So all I know is the final comment in the book is going to be that the profession of architecture, which starts with Alberti, may well be struggling, certainly in terms of the AI and the RIBA, in the age of AI. And by a curious coincidence, the name Alberti begins at A and ends in I. So maybe I'll just put to Silvio this idea that kind of like, and also to Imdat, this idea that actually there is a dystopian side of all this, which is, and it's not because it's bad, but it's because it's terrifyingly amazing. That would be my comment. Sorry for that, again, for that long question there.
Is it okay, Imdat, if I start and then you go next? Yeah. I mean, yes, that's all very, very interesting points, Neil. But one thing I can think of is, I keep saying with a very optimistic viewpoint that until we are in charge, until we are the one writing the algorithm and all that, then it's all good. We can control it. But there will come a time perhaps where, we will be able to write an algorithm that will write an algorithm to do another thing. So in that level of growing complexity, we will lose completely track of what's going on. It's a bit like if you take a neural network that you see quite quickly, the complexity will grow exponentially, which you just lose the control. So you can understand what's going on inside that. You understand the beginning and the end, but not quite what's going on in between. And so if we take this idea and then we just replicate it, then what happens is perhaps there will be an AI that will design an AI to do AI things. And that will be the moment where, we're probably no longer in charge. We have no understanding of what's going on there. Whether it would never happen, I don't know. But I suppose that until we're in charge, until we're in control, it's fine. There will be a time where we will be not, probably. But,
Imdat, would you like to add something?
Yes, I mean, yeah, I think most of I only see you as the sort of super optimist about all these technologies, Neil, and I'm super excited, happy about that. In general, it's more the sort of dark dystopian future that is painted, and yeah, even the Mid-Journey results, right? They all look very dystopian, Blade Runner-like environments rather than blue skies and birds and flowers and so on. But I think I look at the potential in the sense that I studied architecture at a time where CAD was sort of coming, and in architecture schools, they still were sort of, well, no, I need to teach you hand drawing and stuff. And one of the reasons why I picked architecture was because I thought I was super talented, and I had this sort of eye-hand relationship, and CAD came along and all of that lost sort of on importance. Right now, everybody can do architecture, can draw, and now with diffusion models, you even don't need to model, you can just type in a text, right? Anybody can do that. So I'm just, but I think like in music, sort of the talented crop of people, I think, will still be moving forward this practice in a way or the other, whether with AI or not, or, I think that it's like Leonardo da Vinci or Sinan, all these sort of Renaissance. I think this sort of Renaissance architect, the power of the Renaissance architect is eventually coming back a little bit, where all these technologies allow the architect to be have more agency, I think, and be in charge again. I think that's the amazing potential, because with the industrialization, we went into specializations and we became architects, and there were civil engineers and mechanical engineers, you know, whereas Da Vinci was doing everything, right? Or the old masters. So maybe that there's a potential of that coming back, and this really talented people, even though they might not, I mean, draft but they have this sort of, like a talented musician have the eye, the vision, and can use all these sort of new technologies to produce amazing work. I think that will be still there, but the sort of arbitrary boundaries we created as a society, I think that they will shift probably in some way, because of necessity and comfort and the ease of all these technologies. I think. I don't know if I answered your question.
I agree. I mean, I guess the thing is, I mean, I think that what I've seen some of my smartest students have, and I've got to say one thing, that is that they're doing, I got a submission which appeared around Halloween the other day from my students. I give them as an exercise, a Black Mirror episode to produce. and one of them actually was really brilliant piece, because he used 3 bits of AI, and the first bit was kind of like generating a text, which was pretty impressive in itself. And then he used another AI which gave it a human voice, you know, and that was also. And then he used he used Midjourney to go and generate images based on the text. But what was interesting about the text itself was the text generated this piece. It said like. It becomes obvious to us that really human beings are the problem, because they're polluting the planet, so we have to get rid of human beings. So this was like, you know, the Halloween message, as it were. But you know, it is interesting, and I think we've got as educators are going to be aware of the fact we're teaching these individuals for a world in which maybe the notion of architecture itself might not exist in the future, but we also have got to learn from them, and they're showing us the way forward. I mean, they're very much at the age of AI generation. So I think it's you know, so what I always say to my students, it's actually what we should be designing is not buildings, but our future, because, you know, there are ways in which we could harness these technologies and use them in a certain way, but we've got to be aware of that. And to their credit, the RIBA, and I should say that I was going to bring my book out with the RIBA Publishing first of all, and they didn't like the initial title, which is The Death of the Architect. They said, can we have a question mark? I said, no, I want an exclamation mark. And anyway, I eventually shifted to Bloomsbury because I didn't want the RIBA looking over my shoulders and saying, no, we can't say that. But, you know, I think the RIBA actually have been much more open than the AIA. If you look at some of the AI reports, it's like, everything's great. Yeah, it's wonderful. The RIBA actually brought the Suskins in, and they gave a lecture at the RIBA. And they even published a kind of prediction back in 2012, 2013, I think it was, about the future, and which is very controversial, got removed from their website. But there was one comment saying, well, I don't think the term architect is very useful anymore, because what we do, and you know, I think what's interesting is the skill set that architects have, you know, which are much more marketable than we're told. We're told, well, you've got to design buildings, right? But actually, the skill set's incredible. You know, we can think 3-dimensionally, we can design, we can understand material behavior. And there are so many other disciplines in which we can go into, which Helen Carson refers to as other architectures. I mean, here in LA, there are plenty in the movie industry. I mean, a lot of SciAc graduates go straight to the movie industry, or indeed the space industry and so on, and 3D printing. There's a guy who's doing 3D printing sugar here and so on. You know, I think we need to sort of think about that and use our architectural imagination to imagine other possibilities that are out there. So anyway, we have some questions that are coming in. I want to say that we've actually got a really great group here on Zoom, and there's always a good question coming in from YouTube. We've got George Gila here, who's been teaching at the GSD AI. We've got Vaskor in Bangladesh. We've got Ola, who's an interior designer. I'm not quite sure if you thought about your interior designs, which were available. Whether the interior designer goes out of fashion and so on. And we've got Lubitsa, who's working on cities and so on. And Deepti, who was one of the first people to produce the first person to have an AI exhibition in India. So we've got a group here that, and I'd like to invite some questions from the group and also from the YouTube audience. I can see that Vasco's got his video on Vasco. Did you want to ask a question? We can't hear. You're muted. Okay. We still can't hear, Vasco. Maybe put your question in the chat, and I can ask it for you. It might be the simplest thing. In the meantime, Gustavo has put a question in the chat. I don't know if Gustavo would like to ask that question. And certainly, if you want to ask a question, please let me just let me know. Gustavo, would you like to ask yours, or I can also read it out for you?
Hello, Neil?
Yes, hi, Gustavo, hi.
Oh, sorry about that. I just wanted to say thank you very much for the wonderful presentations today. They were really great, and I wanted to basically, I put a few, I guess for Silvio and Imdat, just to give you context, I'm here at UC Santa Barbara, and I'm in the kind of the throes of engineering, physics and mathematics and the sciences. And the lab that I work with is the Alisphere Research Group. And over a decade, we've been looking at the intersections of art and science. And my dissertation is on how architecture fits in to that little, triad. But simply, when you guys presented your books, I really thought about where we are in the sciences. And working with Neil now for a few years, I started to really understand that we're basically put in a box. Like, we're supposed to imagine these problems that are small, but what about the larger problems? Like, so in Imdat, you talked about sorting trash and actually, or waste, and how that can go into different types of works, creative works. And then I thought about the idea of how the other problems that are available, climate. I think Silvio, you had a relationship with climate. How does the profession need to change? How does education need to change? And how does our ethical and moral understanding of computation need to evolve? I think those three questions come to mind. Meeting brilliant computational scientists, a lot of them don't have any understanding about ethics or the arts, and they're actually trying to redefine the profession of architecture or design. Where do you guys both stand?
Shall I go on first? Is that okay? Gustavo, thank you very much for the question. That's very interesting. My experience perhaps is very narrow experience from where I live, but my experience is that there is a kind of forefront of what's going on in terms of computation and experimentation and all that, which happens in offices, more specifically large companies. I think Imdat mentioned KPF or other companies. I mean, they all have, if you look at Zadi, if you look at Foster's, they all have this kind of computational teams. And what they normally do, that's my understanding anyway, they don't produce projects necessarily. They just rotate to design teams to help them, simplifying routines, calculating performance, analyzing sites and all that. So they go around, they help everyone else, they help the designers to make the design more robust. Now, this is proving to be quite interesting and effective, obviously, because when you see a project published or completed, then you see all these marvelous analysis, and they are done by these teams. So, and then you see that happening, which is great, but then you see what happened in academia, especially in places where professional bodies are heavily involved, in prescribing courses and programs. So then you see a resistance to these things. Then you see an emphasis on other aspects of architecture, perhaps more traditional, which is important. It's equally important, is great, but you don't see an opening to computation necessarily. And so on the basis that then industry is not really interested in these things. And so you see what I see bizarre, to be honest, is the fact that there are teams in the profession, in industry, that are at the kind of cutting edge of what's going on in computation. But then these things is not really absorbed and digested into the more traditional institutional elements. It will happen, because I'm sure Imdat students, my students, Neil's students, eventually will be those in charge, and eventually will be totally embedded within everything that we're talking about today. And so if you fast forward 20 years or 15 years, then you will see our students will be the one in charge, and hopefully they will have a completely different understanding of all this. So for me, it's a generational thing. It will just require time, but perhaps colleagues might have different opinions.
Yeah, I just want to add to Silvio's answer, and I think those are very deep philosophical questions in a way, Gustavo. I mean, I think, I mean, if we talk about the moral and ethics, right? I mean, that was why we got sued by AIA, right? Because they were saying we are sort of against the code or the ethics of things. And, I mean, it didn't went anywhere, but the question is, what morals? Is it like, I mean, if you think about Kant's, categorical imperative, right? Do I want everybody to do what I'm doing, and is the world a better world in that case? I think yes. I think that's I think morally, philosophically, I think it's the right thing to do. And I mean, does it add value? Does it add? Does it beautify the world? And if the answers to all of this, I mean, you could then actually turn it around and say what you guys are doing is actually not morally right? If there is this potential of this technology to make people's life more comfortable, more more happier, and then beautify the world, then not doing and fighting against is, I think, morally probably not right. In terms of, I mean, in the startup ecosystem, my experience was, especially in Boston, that a lot of, I mean, there is actually a graph since 2015, like 90% of all startups that looked for money from venture capitalists are actually doing some sort of AI, AI in fintech, AI in health, AI in whatever. And VCs got also a little bit sick of that, fatigued by it. But the usual modus operandi of that is actually developing teams where you have a domain expert, like let's say an architect, and sort of a computer programmer or developer. And you have either an architect and a developer, a doctor and a developer, a lawyer and a developer, that's sort of the natural formations in these venture capital environments. I think in education, I feel like this sort of interdisciplinarity, I mean, we talk a lot about it, but practically we are still living in our silos, especially in these traditional schools. Like at Harvard, right, the GSD is very sort of, separated. Even at MIT, right, when you're at the architecture school, yes, Media Lab is part of the architecture school, but it's a separate world, it's not as sort of poor as one might think. But these type of collaborations and interdisciplinary work, I think, has to be fostered in education, where architectural students work together with these computer scientists. For example, in my group, we are working on the future of the city. We have a doctoral student who has an undergraduate degree in computer science, and then came to architecture school. And I try to sort of hook up these type of different, domain experts and sort of more tech people. And I think until now, it works really great. I mean, that would be my 2 cents to your question, Gustavo. But I think definitely, you could write a book about just that, about the moral philosophy of where things are going with AI. I think that would be an interesting thing to read.
I just wanted to thank you both for your for your answers, and thank you for your time. And Neil, as always, you're an inspiration. Thanks for the entire course. It's been wonderful.
Well, thanks, Gustavo. Gustavo is part of our team, actually, Digital Futures. Such a fantastic team member. Wonderful. So I got Vascor's question. Vascor is in Bangladesh. I should just say that the whole world is watching this. I just got a comment from Michael Just, who's getting off a train in Berlin. He's literally, so we've got Vascor's in Bangladesh, so we're literally all over the place. But let me just read out Vascor's question because he can't, I think the microphone's not working properly. Vascor, thanks for the question. The question is, we all know that politics and architecture are in a close relation. We find it even in modern times when Tony Blair and Francois Mitterrand use iconic architecture to prove their regime. Is there any chance that AI-based smart cities may grow as a political decision? I've got an answer on this, but I want to hear your answers first of all. So let me read this out again. We all know that politics and architecture are in a close relationship. We find it even in modern times when Tony Blair and Francois Mitterrand use iconic architecture to prove their regime. Is there any chance that AI-based smart cities may grow as a political decision?
Silvio.
No, you go first. I always go first. You go.
No,
first.
I just have 2 cents. All decisions about cities are political. There is no alternative, I think, especially I mean, I'm working on Future City, and everything we do is political, actually, in a way. I mean, we are in the research lab. We are not dealing with the politics of it, but when it comes to implementation, right, there are so many aspects to it, and it's all political. Even if it's a bad city or good city, smart city, AI city, whatever we are talking about. So I think in that way, AI doesn't offer sort of an alternative grassroots solution because it's dealing, unless AI can rule cities, like that's another thing, right? Why don't we automate the city? Why do we need still parliaments and representational democracy, right? If you can do a direct democracy and participatory models, I mean, those could be interesting things, but I think we are super far away from politicians leaving their power structures and giving it away to machines, machines right now. Okay, that's my 2 cents, Ashik.
I mean, there is one aspect of smart cities, which is control and management of assets and things like that. And that side, politicians will really like. If you think about the whole thing about dashboards and, kind of resource management and controlling air quality and things like that. I mean, that aspects politicians will really like, and they favor, we all know of the example of, was it, in Brazil, was it Sao Paulo or something? Or, they put up all this massive kind of smart city network and monitors everywhere to kind of try to have sort of almost making a city that inherently is not smart, but making it smart just because they benefit from having a little bit of an overview and of everything is going on there. So, I mean, you have that, but also you have, as we all know, this kind of top-down smart cities, and we're all talking about now about this kind of 1 mile or whatever 100-mile cities. It's just this immense project, and that's a classic example of, if you like, could be clustered as a smart city. I don't know, but I have to see the project. But it's a top-down intervention. You might argue made by politicians or whoever wants to develop that. And we have example of Masdar, Songdo, a little bit everywhere. So those are political decisions. I mean, the other thing of the aspect is that in other parts of the world, that you have, like in the UK and France, you have politicians who positively and actively talk about AI as, they want the country to become an AI science, AI superpower. And you can see that. You can read in articles. You can see them, speaking about this and quite openly. And so there is this kind of intention and willingness to embed AI in politics, in development, in economics. not necessarily architecture or smart cities, we will intend it necessarily, but I think sooner or later the two things will probably align, I'm guessing.
But yeah, maybe I could just kind of, this really, it should be for you guys to answer, but I just like, since Vasco raises the question, I actually published an article in Domus years ago when Tony Blair was in power about and it was called Camouflage London, and it was and what I was arguing actually is that I mean, going back to this question about the visuals, and of course I get obsessed with visuals, and I said, well, there's a danger that you judge Tony Blair by the architecture that he produces, and I was talking about these glass boxes, right? And you know, the headquarters of the Foster Design little blob, it's headquarters of the Greater London Council, I think it was called anyway. And I was saying, no, actually, really, if you want to look at the contribution of what's happening there, don't look at the logic of representation, but look at the other mechanisms, because they seem to suggest an openness, a glass building, like Foster's Reichstag, accessibility, you can see democracy in action, isn't that fantastic? Well, not really, because you have no access to that, right? And despite all these kind of glass boxes, you only get access to them, you've got the right credit card. And the real logic I came up with is, say, in terms of Tony Blair, there is an architecture of exclusion going on in London, and it's based on the cost of the properties. Now, you can go and access these restaurants if you want to, if you pay enough money, but the point is there is exclusion going on, because we can't all live where we want to. There's another sort of logic behind it. So that was what I was arguing in that particular book. But what I would say is, of course, architecture has been linked to politics, Albert Speer, the word in stone and all that. But there is a slight problem in the sense that it really depends on when it's happening, because, if you take for Ceausescu, for example, there's a building associated with Ceausescu, and it had a very particular political label. But that label can be changed, right? I mean, that building, the Ceausescu's palace, is now the Parliament building for Bucharest, and it's been transformed. So we can't attach a particular message and fix it to architecture. I mean, if you just take the AA, we've got one in our audience here, someone who studied at the AA. The AA was the building, 36 Bedford Square, where it was 36, 38, whatever it is. It was designed as a house. But if you use it in a certain sort of way as a school of architecture, if there are certain practices in operation there, which is to say, seminars, lectures, and whatever happens in a school of architecture, you redefine the politics of the place. Much as I think, the way in which we understand words, it's really a question of how you use that word. One word in one context will mean a different thing to the same word in a different context. And I always use the example of a tennis game where somebody kind of, I do a shot that my opponent can't get it, and he said, "You bastard." It doesn't mean that he's calling me illegitimate, right? It's just simply what you say on the tennis court and so on. So I think that the distinction between the architecture and politics is a little tricky. And I would always focus on the work of Judith Butler, who was really looking at how we perform politics. In her case, gendered politics. Her argument as a lesbian theorist is to say that because I've got two breasts doesn't mean to say I've got to be a heterosexual housewife kind of thing. I can redefine myself by performing in a certain sort of way. So I think the question of politics, I've got a book that I should have completed for Routledge already called The Politics of Space, is a bit more complex and nuanced than that. Sure, within a particular culture, you can produce a particular building, but that doesn't mean that the political label will be effective. But I completely agree with Imdat's comment that everything is, in a sense, political, in the sense that everything is ideological. And I think there's a comment by Stanley Fish, there's no such thing as free speech, and it's a good thing too. And what he's saying by that, there's no utterance we can make from any sort of platform that isn't constrained by the politics of that platform. And I think the big mistake in America right now is for people to think they're free. I mean, they're absolutely not free. They're kind of constrained by a kind of a liberal, I don't know what you call it actually, but a kind of a market economy, a kind of, that's the pervasive thing. I always think in the States, whenever I watch TV and see all these advertisements, that we're kind of indoctrinated by a kind of a commercial world out there. But anyway, that would be my my 2 cents worth. It's a difficult, challenging question, that. I'm just looking to see if we've got any more questions there. It's Felice. Felice has got a question. Felice Grodin for Imdat, and Felice was actually I don't know if she was there at the GSD with you, but she was she studied at the GSD and is now on the FIU DDes. Felice Grodin's question, and she can't ask it, she's in a noisy family situation, so let me just read it out to you. It's in the chat as well if you want to look at it. Imdat, I think that you mentioned that the term the avant-garde, is that related to aesthetics or something else in your view? If it's something else that you do you think that there is a detachment between avant-garde aesthetics, avant-garde and aesthetics, and is that being accelerated by AI? Let me read that again. Imdat, I think that you mentioned the term avant-garde. Is that related to aesthetics or something else in your view? If it's something else, is there a detachment between avant-garde and aesthetics, and is that being accelerated by AI?
Yeah, a good question. I mean, not to get confused, I didn't mean it in the sort of historical stylistic sense as the avant-garde of modernism, let's say, but more as the progressive next step. Well, what's the next step? I mean, we had modernism, postmodernism, parametric design, now AI. What's the aesthetics of it? What's the true nature of this? What does AI want to be? Right? That's even the danger that I'm seeing when I was talking about inbreeding is, can it do it eventually? You know, is there some AI aesthetic that will come out of this, or is it just sort of spilling whatever we already know and have created, like the diffusion models, right, using trillions of images and giving us new sort of composition and Frankensteins. Whereas, I mean, I believe that composition itself is also a creative act. I mean, it's not, it's the way we architect, so we never sort of come up with something, I guess, totally out of the world, but is I mean, that was sort of my question about this. Is AI sort of prone to inbreed and just reinforce whatever we had already producing, or will there some sort of AI aesthetic or architecture avant-garde come out of this by us as designers or by the AI itself? You know, that was sort of my question. I'm not sure if I answered you on that, but please follow up if probably it's not satisfying the answer, but that's sort of my thinking. I just also, Neil, wanted to add to what you were talking about at the end. There is a term that Shoshana, I forgot her last name, but she calls this surveillance capitalism, right? That we are tracked, and Google and Facebook and all these sort of big giant tech companies know more about us than anybody else, than ourselves even. So on one hand, we have surveillance capitalism in the free world, let's say, in the Western world, and in the East, we have different type of surveillance. But in either way, one feels a little bit arrested, right? What is sort of the democratic way of doing this? And do I have a right for privacy? Do I have a right to be not known? Do I have a right for committing crimes? I mean, for doing wrong, right? I mean, maybe we are drifting into a world where you cannot no longer do any wrong, but maybe that's also a right. I mean, I don't know. Those are all, I think, going back to Gustavo's question about morality and ethics and so on. And do we want to live in a surveillance world, you know? And if not, what are the answers? I mean, we need these technologies. They provide a lot of comfort to us. How can we do this the right way? I mean, that's my utopic sort of hope, rather than the dystopia that looks like is emerging.
Yeah, maybe I could just a sort of comment to Felice. okay, one second. I lost my train of thinking there. Yeah, okay. Yes, I think just in terms of aesthetics, I think, one thing the term that I love when I'm talking about these tools is the term affordance, J.J. Gibson's term. I think it's really useful. It's not as though it has any agency. You can't force us to do certain things, but there are some things you can do with certain tools you can't do with others. I mean, going back to Alberti, when the computer was just coming in Cambridge, and we were banned from using it in the studio, right? Delabore Baisley would say no. And of course, as a result, we had a whole generation of graduates coming out who were unemployable because they couldn't use computers. But, I think, in terms of you think about what you can do now. And when I was a student at Cambridge, I did a study of the Sydney Opera House, which is kind of interesting because, in those days, it was kind of parallel motion, and you could very easily do sort of straight lines, and you could do, the logic was basically that of a kind of rectilinear logic. And when it came to Sydney Opera House, the problem with Jornutz's amazing sketch is that nobody knew what the hell it was. I mean, you couldn't define the points, right? And so in the end, in order to make the Sydney Opera House, they had to analyze as segments of a sphere, so they could calculate it from an engineering point of view. So the Sydney Opera House is actually the vaults, and no longer that free form thing, but they're actually segments of a sphere. And I think now that we can use the computer, it allows us to to do certain sort of things to define curves. I mean, Zaha's office, it's clearly hugely important. So the question is ultimately, what are the affordances of let's say Midjourney, all these things for the moment, right? And it does seem to me there is a rather, I see too much this kind of rather glitchy stuff going out on the internet with early stages. And there is a certain aesthetic that it unless you're critical about it, there's one amazing office that does this minimalist architecture using Midjourney. I don't know how they do it. Studio Arcan, I think it's called, but anyway, beautiful stuff. But on the whole, there's a kind of sameness because it does tend to sort of produce a certain sort of aesthetic. But I just wonder whether, what it does, it is very good at, is a kind of almost Baroque-like ornamentation in terms of the visuals, and it does generate that. And I'm wondering whether, in a sense, the role is going to be that it's going to be a prompt. We write the prompts, but it prompts us. Whether there'll be a new kind of flourishing of visual-based materials, and now that you can 3D print things and anything can be made, I suspect that we might find some impact coming in from that. But let me just throw that out as a kind of comment. If anyone wants to pick up on that. And of course, I guess the key question is really, this has come out in the presentations today in the sense that, the amount of time that's going into the books, these things have a kind of 3 or 4 year history. By the time they come out, especially, I see it's almost exactly the same as I had a 1 year from kind of manuscript delivery to production. In that 1 year, goodness knows what happens. All those books are out of date now because of in terms of illustrations anyway, because of these diffusion platforms and so on. And who knows what it's going to be in the future. But I guess that, I still kind of stick to the point that actually that these diffusion platforms are just a distraction. They're nice sketching tools. They can do amazing things. But the real answer is actually in what is the software that's been developed right now in offices like X-School or I guess Autodesk is also producing things with the SpaceMaker and so on. That's my kind of view that in the end, it's going to not be aesthetics so much as kind of like in the end, I think cost constraints and so on. That'll be probably the main driver. So we should try and wrap things up. This has been a fantastic discussion, and I don't want to stop it because I want to continue at another stage. I think what we've done is just, what's interesting about this series is that really the books become a medium through which to talk about, in this case, the city. And I think such interesting comments have come up as a result of this today that, lots of food for thought. And I think actually just bringing together people in this way is such a dynamic platform in which we can discuss ideas. So maybe we should try and wrap up because it's going on for a long time. And Simon is in China where it must be gone midnight now. But so I just wanted to say this has been fabulous. Thank you so much, Imdat and Silvio. It's great to be able to speak to you in your accent and your voice. Silvio, I wish you didn't have your British accent. I love the Italian accent. But anyway, it's great to come together and have this discussion. Let's take it further. And just to say, we are uploading all these videos onto YouTube. We're getting a lot of people watching these things, which is great. I think one of the previous sessions is now up to almost 200,000 views. I mean, hopefully this platform itself will become more significant, because I think the possibilities of what we can do, especially in terms of doctoral consortium, because typically what happens with doctoral researchers is that they all work in their silos with their individual professors, and when you create a platform when everyone can come together, then something magical can happen. It's just, since Silvio is here, just to say that I studied Latin, obviously, and the word the word computation comes from the Latin compute, to think together. And I think we have a form of computation happening today, a kind of form of global brain, and this idea of getting a platform together, I think, has been very productive. So let's wrap up now, but let's continue the discussion. So thank you so much. Thank you, Silvio. Thank you, Imdat. Thank you those on the Zoom call, and thank you those who are kind of sending messages in from YouTube. Thank you also to the Digital Futures team that's behind this, especially to Pavlin, and also to Gustavo and others. There's just a comment here from this is a comment. Thank you from Berlin, from Michael Just. But these things couldn't happen without people generously giving their time and sharing their passion for architecture. I think this is the most important thing, is that we are all passionate about architecture and sharing our ideas, the sharing economy. It's great to see people contributing so much. So thank you. Oh, wait a minute. There's a final question from Deep T. Let me think. Imdat, you mentioned, what does AI want to be? Well, answering Felice's question, such an interesting and fresh way of looking at AI reminds me of Louis Kahn asking the Brit, what does he want to be? I wonder about the same too. What does AI want to be? Maybe I'll leave you to make a final comment on that, Imdat.
I'm so excited. I think you guys are doing a fantastic job. This should have been done. I mean, the Digital Futures team and what this could be sort of a global doctoral seminar, and it totally makes sense. I mean, I know how dull our doctoral seminars were, so I think this is fantastic, and thank you guys for doing this and for inviting me. And I also want to say to Silvio how much I admire him, having these 146 contributors in a book. And I know how difficult this editing business is. I mean, these are the two only books that I edited, and I say no more, because it's like a lot of hand holding and emails and hours, and I know how difficult it is, and having so many contributors is really amazing. And so I truly admire, and thank you. To answer the question, yeah, it's probably deep in my mind there was Louis Kahn, but yeah, I hope there will be some aesthetic that comes out of this, and we have to sort of try, and it's sort of, as you say, maybe a collaborative or a global thing, that it will just, it's amazing. I mean, you also had David Chalmers talking about consciousness, and Memo was also talking about this stuff, right? Maybe all this, what we're doing, will generate collectively, this sort of, the new aesthetics will come out of sort of collective design intelligence. I'm not sure, but yeah, I definitely look forward to that, and it will come out just from these type of exercises, I think. So,
if I may say, just Neil, quickly, I just want to echo what Imdat said, and it's been a very great experience, and thank you very much.
Yeah. Well, let me just can I quickly just answer Deep T's question? I think, if you ask, what a brick would want to be, that's ventriloquism. I'm sorry, it's a ventriloquism, because bricks don't talk. And I think this kind of points towards something kind of interesting in terms of AI, in terms of the history of the summer, there was a I'm trying to remember his name now, Blake Lemoine, this kind of a Google engineer who was thinking that the AI was conscious. That also was a kind of form of projection of anthropomorphizing AI. And I think the point is that you've got to be careful about that. You know, what does AI want to be? It doesn't even think, right? It can't, it's we're in a different sort of territory. But I do think this kind of, it raises important questions that actually, not just about AI, but about humans, about the way that humans operate. And that's why I think some of the early discussions we've had with Memo, with Yosha Bach and so on, it actually, in the end, it becomes a mirror in which we can think about ourselves. Not that we're the same, not there's a direct reflection, but AI becomes a mirror where we can think about human society. And I think that's really, in many ways, where we can sort of develop a theoretical and philosophical discourse about, you know, how we do this, and particularly taking on board the new kind of paradigm, which is to say cognitive science, less the whole old world of French post-structuralist philosophy, Derrida and Deleuze, and more these kind of cognitive science thinkers, neuroscience, AI thinkers. And that's, I think, where we get in this incredible melting pot, not just of arts and science, but also of the academia and industry coming together. So anyway, let's wrap up. It's been fantastic, and let's meet again some point and continue this debate, because I think it's such an important debate. Thank you so much for your contributions, Imdat and Silvio. Thank you for the team, and thank you for everyone who's joining us. This is the last one in the series. We will have another series next semester, and there'll also be a Tongji-based one in the summer, series in the summer. So let's continue the discussion. Thank you, everybody, and see you again next semester. I would just finally say that there's going to be something on the FIU DDes, inside FIU DDes. Yesterday we had inside Tongji, where we looked at the doctoral research going on in Tongji in China, and there's going to be another one. We're going to carry on and do many more in the future. So looking forward to things in the future, and thank you again to everyone. And